Methods of solution of truss members. We have two methods of solution. The first one is the joint method. We have our truss here with all external forces applied on it. The blue forces are external forces. The green forces are the reactions. Considering the joint method, we assume tension forces just for convenience in all members of the truss. Here you can observe that for each member, the internal force is resembled by two arrows heading towards each other, which means it was assumed to be a tension members. In other words, we can observe any joint of the truss and conclude that all arrows of the internal forces are heading outside of this joint. This really indicates that all members connected to the joint were assumed to be tension members. Extracting joint D outside, we can analyze the force in DC to a horizontal and a vertical component. For joint methods, two equilibrium equations can be applied. The first one, the forces in the x direction equals 0. The second one, the sum of the forces in the y direction equals 0. Here the x and the y directions are the horizontal and the vertical directions respectively. Of course, for any other complicated problem, we can assume x and y axes to be any two perpendicular axes, not necessarily horizontal and vertical. Forces that are included in those two equations are external forces and internal forces of members connected to the joint. The second method is the section method. We consider again our truss here. We have a section, which means cut in the member. This cut divides the truss into two separate parts, and we can consider any part. Now let us consider the left part. We extract it here with all external and internal forces. The internal forces in the section methods are the forces of the members that had the cut passing through. So in our case here, this cut passed through three members. Those three red members are the only members that can appear in the equilibrium equations fulfilling the section method. For this second method, we have three equilibrium equations. Sigma forces in the x direction equals 0. Sigma forces in y direction equals 0. And sigma moments about any point equal 0. After analyzing the force in DC into a horizontal and a vertical component, we can easily compute or apply any of the first two equations. We know that for the section method, it is very wise to apply one unknown in one equation as much as we can. So we are always trying to find one equation which deletes or crosses out all internal forces except one to be computed, just for the simplification of computations.